Hello learners, welcome back. In today's session, we are exploring an innovative construction technique, that is precast construction part 2. In the previous session, we have discussed about precast construction part 1. So, precast construction is revolutionizing the industry with its efficiency, quality and sustainability. In this session, we will delve into various aspects of precast construction, including its advantages, processes and applications in modern construction projects. Let us start with the topic of transportation and handling. So, transporting precast elements from factory to the construction site requires careful planning. The size and weight of the components dictate the type of vehicles and routes that can be used. Additionally, elements must be protected from damage during transit, as even a small crack could compromise their structural integrity. If we could take one real world example, for a project like a bridge, precast girders might need to be transported over a long distance, requiring special permits and escorts due to their size. The logistics of moving such large components can be complex, involving coordination with local authorities and careful planning to avoid disruption to traffic. During transportation, components are often secured using specialized equipment to prevent movement or damage. The use of padded supports and protective coverings can help minimize the risk of damage during transit. Moving on to the topic of strategies in the part of transportation and handling. To address these challenges, modularization is often used. This involves designing components in smaller sections that are easier to transport and handle on site. Efficient logistics planning is also essential to ensure that the right components arrive at the site at the right time, preventing delays and disruption in the construction process. Taking one practical application, that in urban construction projects where space is limited, just in time delivery is often employed. This strategy ensures that components arrive at the site exactly when they are needed, reducing the need for on-site storage and minimizing the risk of damage. Modularization also allows for greater flexibility in design and construction. Smaller components can be combined in various ways to create different layouts or configurations, providing greater adaptability to the specific need of the project. Moving on to our next topic, that is installation and erection of precast elements. It is equally an important topic. Taking first point in this is foundation preparation, whose objective is to ensure that the foundations are fully prepared and capable of supporting the precast elements. The steps involved in this is firstly we have to verify the strength and levelness of the foundation, ensure all anchor bolts, inserts, embedded plates are in place as per the design specification. Proper foundation preparation is critical as it impacts the alignment and stability of entire structure. If you could take one practical example, for example, a precast wall panel, the foundation must be perfectly level to avoid any misalignment during installation. Next point in this category is positioning. Objective is to accurately position precast elements using cranes or other lifting equipment. Steps involved in this: firstly, use cranes to lift and position each element precisely as per the layout plan, and then utilize guides such as laser levels or alignment marker to ensure accuracy. The correct positioning of element is vital to ensure the structural integrity and aesthetic alignment of the building. During installation, slight adjustment may be necessary, so ensure that positioning equipment allows for fine tuning. Next is the connection. Objective is to secure the precast elements in place using the appropriate methods such as bolts, grouting or welding. Steps involved in this is to align the elements with pre-installed connectors or embedded plates using bolts, grout or welding to secure the element together depending on the design. Connection must be secure to ensure the load bearing capacity and overall stability of the structure. For example, in a precast beam column connection, bolts are tightened to specified torque values to ensure a firm connection. Next point is of integration. Objective is to integrate utilities, finishes and other systems with installed precast elements. Steps involved in this is to coordinate the installation of electrical conduits, plumbing, HVAC and other systems with the precast elements, and then apply finishes such as sealing joints, painting or cladding as required. Integration ensures that the building functions as a cohesive system with all the utilities and finishes properly coordinated. If you talk about the practical insight, we have to plan the integration process early to avoid conflicts between structural elements and building systems. Moving on to the last topic of this, that is quality checks. Objective of it is to perform quality checks to ensure that all the precast elements are installed correctly and meet the required standards. Steps involved in this is to inspect the alignment and levelness of installed elements, is to verify the stability and integrity of the connections, conduct any necessary testing such as load testing or non-destructive testing of welds. Thorough quality checks prevent future structural issues and ensure the safety and longevity of the building. For example, after installing precast floor slabs, check for proper alignment and levelness to ensure the even distribution of loads. Moving on to our next topic, that is the advantages and disadvantages of precast construction. Talking about the advantages, firstly we will talk about the quality control. There is high standard in factory conditions. Precast elements are manufactured in a controlled factory environment, allowing for stringent quality control. Factors like temperature, humidity and curing time can be precisely regulated. This control ensures consistency, reducing the likelihood of defects and ensuring that each element meets or exceeds required standards. For example, precast beams and panels are often of higher quality than those cast on site, resulting in fewer structural issues over time. Moving on to the next advantage, that is speed. There is faster construction timelines. Precast elements are produced off-site and delivered ready for installation, which significantly reduces on-site construction time. Elements can be manufactured while site preparation is underway. This leads to faster project completion, making precast construction ideal for projects with tight deadlines. For example, in a commercial building project, using precast component can reduce the construction timeline by several months compared to traditional methods. Moving on to the next advantage, that is durability. It will give enhanced material properties will be there. The controlled manufacturing process allow for the use of high performance material and precise mixing, leading to stronger and more durable elements. Precast components often have higher strength and durability, leading to longer lasting structures with lower maintenance needs. For example, precast concrete elements are often more resistant to environmental factors like freeze thaw cycles, ensuring longevity even in harsh climates. Next is reduced site disruption. There is less on-site labor activities are there. With most of the construction work done off-site, there is less disruption at the actual construction site. This means fewer workers on site, reduced noise and less waste. This advantage is particularly important in urban areas where minimizing disruption is crucial. For example, in a busy city center, using precast element reduces the impact on surrounding business and resident, as on the on-site assembly is quicker and quieter. Moving on to the next advantage, that is versatility. It is suitable for various structural design. So, precast concrete can be molded into a wide range of shapes, size and finishes, making it suitable for various architectural design and structural applications. This versatility allows architects and engineers to achieve both functional and aesthetic goals. Taking an example, that precast panel can be designed in a decorative finished patterns or even embedded colors, offering flexibility in design. So, if we talk about the disadvantage, the first that comes in mind in the initial cost, that is higher upfront investment is there. Precast construction requires a significant initial investment in molds, specialized equipment and detailed planning. The cost of these molds can be high, particularly for custom or complex designs. Although the long term benefits may outweigh these costs, the higher initial expenditure can be barrier for some projects. In a small scale project, the cost of creating custom molds for precast elements might be prohibitive compared to traditional construction methods. The second disadvantage is the transportation limits due to size and weight restrictions. The transportation of large precast elements can be challenging due to their size and weight. These limitations can restrict the dimension of precast components, especially in the construction site is when construction site is far from the manufacturing plant. Transportation challenges can lead to additional costs and logistical complications. For example, oversized precast element may require special permit, route and even escort vehicles for transport, adding to the complexity and cost of the project. Next disadvantage is the design limitations. There is complexity constrained by manufacturing capabilities. While precast construction is versatile, there are limitations in terms of the complexity of shapes and sizes that can be manufactured. Highly intricate or unique designs may not be feasible or may require costly custom molds. The manufacturing capabilities can limit design freedom, particularly for projects that require non-standard elements. For example, a building with highly irregular or organic shape may not be suitable for precast construction, as the complexity could drive up cost or make production unfeasible. And the last is the dependence on suppliers. Coordination required for timely delivery is there. Precast construction heavily depends on the timely delivery of components from suppliers. Any delays in production or transportation can disrupt the construction schedule. Coordination between the construction site and the precast manufacturer is crucial for maintaining the project timeline. A delay in the delivery of precast floor slabs could halt the entire construction process, leading to costly downtime and rescheduling of labor. Moving on to our next topic, that is the application of precast construction. Firstly, we will talk about the residential buildings, that is the apartments and housing complexes. Precast construction is widely used in residential projects, particularly for multi-story apartment buildings and large housing complexes. The use of precast elements like wall, floors and staircases allow for rapid construction and high quality finishes. Its key advantages include the speed, that is faster construction timelines enables developers to complete projects quickly in reducing time to market, and the quality, that is factory controlled production ensures consistent quality, which is essential for residential projects where safety and comfort are paramount. If we could take one example, that in a high rise apartment building, precast wall panels and floor slab can be installed quickly, reducing the overall construction time and allowing for faster occupancy. The next is the commercial structures, that is the office, malls and hotels, etc. Precast construction is ideal for commercial structures where large open spaces are needed and aesthetic appeal is a priority. Precast components can be designed to meet specific architectural requirement while maintaining structural integrity. If we talk about its advantages, that it is versatility and durability. Versatility, that is the precast element can be customized with various finishes, colors and textures to meet the design requirement of commercial spaces. And if we talk about the durability, the high strength and durability of precast element make them suitable for building with high foot traffic such as malls and hotels. Moving on to example, a shopping mall can use precast column and beams to create large open spaces without the need for numerous interior supports, enhancing the shopping experience. Next is the industrial facilities, that is the warehouses and factories. Industrial facilities often require large unobstructed spaces and strong durable structures. Precast concrete is well suited for these needs, providing robust solution and can withstand heavy loads and harsh conditions. Its advantages include load bearing capacity and the resilience. Talking about the load bearing capacity, precast elements can be designed to support heavy machinery and equipment commonly found in factories and warehouses. If we talk about the resilience, precast structures are resistant to fire, chemicals and impact, making them ideal for industrial environment. Taking one example, a warehouse might use precast concrete panels for its exterior walls and precast beams for its roof structure, providing a sturdy, secure and environment for storage and operations. Talking about the infrastructure, that will be bridges, tunnels, parking structures, etc. The infrastructure projects benefit significantly from precast construction due to the need for precision, durability and speed. Precast components are often used in the construction of bridges, tunnels and multi-level parking structures. Advantages include the precision, that is the factory control environment ensures the precast elements are manufactured to exact specifications, which is critical in infrastructure projects. And if we talk about the durability, precast concrete resistance to environmental factors such as freeze thaw cycles and corrosion makes it ideal for long lasting infrastructure. If we take one example, a precast bridge deck can be installed rapidly, reducing the disruption to traffic and the environment during construction, while providing a long lasting solution for the roadway. There are some special projects also, for example, sport arenas, educational institutes, etc. Special projects like sports arenas, stadiums and educational institutions are often require unique architectural design, large open spaces and structures that can accommodate large number of people. Precast construction provides flexibility and strength needed for these projects. Advantages include the customization, that is the precast element can be tailored to meet the specific needs of special projects, including complex geometries and custom finishes. And secondly, that is the speed and efficiency. The rapid installation of precast component is crucial in large scale projects where deadlines are tight, such as for sports venues. For example, a sports arena might use precast concrete for seating, tires, walls and roof structures, ensuring both durability and the ability to meet the unique design requirement of the venue. Moving on to our next topic, that is the design considerations in precast construction. First, we will talk about the structural integrity that ensures the load bearing capacity. The primary consideration in precast construction is the structural integrity of the elements, ensuring that they can support the required loads and stresses over the building's lifespan. This includes both vertical load and the lateral load. We talk about the material strength, use of high quality materials and precise manufacturing process to achieve the necessary strength. Next, we will talk about the design calculations. Engineer must perform rigorous calculation to ensure that each precast element meets or exceeds the required load bearing capacity. For example, in a multi-story building, precast beams and columns must be designed to handle both the weight of the floors above and the dynamic load, such as those caused by occupant moving within the structure. Next is the thermal and acoustic performance, which enhances the comfort. Precast elements contribute to the building's thermal and acoustic performance, which are critical for occupant comfort. Thermal performance refers to the element's ability to insulate against temperature changes, while acoustic performance involves reducing noise transmission. Thermal insulation, that is integrating insulating materials into precast panels, can improve energy efficiency, reducing heating and cooling cost. If you talk about the acoustic insulation, precast element can be designed with layers or materials that absorb sound, minimizing noise between rooms or from outside. For example, in a residential building, using Insulated precast wall panels helps maintain a consistent indoor temperature and reduces the need for additional heating or cooling system, while also dampening noise from adjacent apartments. If we could talk about the aesthetic, that is achieving desired visual appeal, aesthetic considerations are crucial, especially in projects where visual appeal is priority. Precast construction offers a wide range of finishes, textures and shapes, allowing for flexibility in design. If we talk about the surface finishes, precast elements can be finished with various textures, colors and patterns to match the architectural vision of the project. Architectural flexibility, designer can use precast components to create intricate details such as decorative facades or unique geometric shapes. For example, for a commercial building, precast panels can be designed with a specific pattern or color to reflect the brand identity, while also providing the structural benefits of precast concrete. Next is the integration with other systems, that is electrical, plumbing, HVAC, etc. Precast elements must be designed to integrate seamlessly with other building systems such as electrical wiring, plumbing and HVAC, that is heating, ventilation and air conditioning. This requires careful coordination during the design phase to ensure that all the systems can be easily installed and maintained. If we talk about the embedded conduits and fixtures, precast panels can be pre-fitted with conduits, ducts and other fixtures to facilitate an installation of electrical and plumbing systems. There is system coordination to ensure that all building systems are considered in the design of precast elements to avoid conflict or the need of costly modification on site. For example, in a hospital building, precast wall panels might include pre-embedded electrical conduits and opening for HVAC ducts, allowing for quick and easy installation of critical systems. And lastly, if we talk about the flexibility that accommodates future modification, building often need to be adapted over time to accommodate new uses, technologies or occupant needs. Precast construction should consider the potential for future modifications, allowing for changes without compromising structural integrity. Talking about the modular design, precast components can be designed for easy removal or replacement, facilitating renovations and expansions. If we talk about the adaptability, design precast elements with the possibility of future alteration in mind, such as adding openings for doors and windows. For example, in an office building, precast floor slabs might be designed with voids that can be opened later to accommodate new staircase or elevator shaft, providing flexibility for future reconfigurations. Moving on to our next topic, that is quality control in precast construction. Quality control in precast construction is essential to ensure that all elements meet the required standard of strength, durability and precision. This involves rigorous testing, inspection at various stages of production and installation. Firstly, we will talk about the material testing, that is verifying concrete mix and reinforcement quality. Quality control begins with the testing the raw materials used in the concrete mix, including the cement aggregate, water and admixtures. Ensuring the correct proportion and properties of this material is crucial for producing high quality precast elements. Concrete mix testing, that is regularly tested concrete mix for consistency, workability and strength. Common tests include the sum test, compressive strength test and air content test. And if we talk about the reinforcement testing, inspect and test the steel reinforcement for tensile strength, ductility and adherence to design specification. For example, before casting precast beams, the concrete mix is tested to ensure it will achieve the desired compressive strength, and the reinforcement is checked for proper placement and quality. Next is the dimensional accuracy, ensuring components meet specifications. Dimensional accuracy is critical in precast construction, as even small deviations can lead to misalignment and structural issues. Precision is in the manufacturing process ensures that each component fits perfectly with others on site. Talking about the mold calibration, regularly calibrate and inspect mold to ensure that they are producing elements with the correct dimensions, and the dimensional check, that after casting we have to measure each precast element to verify it meets the specified dimension, including length, width, height and thickness. For example, precast wall panels, dimensional checks are performed to ensure that each panel will align correctly with adjoining panels, avoiding gaps or overlaps. Moving on to the surface finish inspection, in which we check for defect and consistency. The surface finish of precast element is important for both aesthetic and functional reasons. Inspection focus on identifying any defects such as cracks, air voids or irregularities in the surface texture that could affect the element's appearance or performance. The key practices include the visual inspection, that is conduction of visual inspection of each precast element surface to identify defects like cracks, chips or inconsistencies in texture or color. And second is the finish consistency. We have to ensure that surface finish is uniform across all elements, especially in projects where appearance is crucial. For example, in a project involving precast facade panels, the surface finish is inspected to ensure a consistent appearance across the entire building, contributing to its aesthetical appeal. Moving on to the next testing, that is load testing, validating structural performance. Load testing is performed to validate that the precast elements can withstand the loads they are designed for. This includes both static and dynamic tests to stimulate the conditions of the structure that will face in real life. The key practice include the static load testing, in which we have to apply control loads to precast element to verify that they meet the design specification for strength and deflection. And the next is the dynamic load testing, that is test for performance under conditions such as wind load, seismic activity or other dynamic forces, especially for critical structure component. If we take an example that before installing precast bridge girders, load testing is conducted to ensure that they can handle the anticipated traffic loads without excessive deflection or failure. And the last is the documentation, maintaining records for traceability and compliance. Thorough documentation is crucial for maintaining quality control throughout the precast construction process. It provides traceability, ensures compliance with standards and serves as a record for future reference or audits. Its key practices include the production records, in which we have to keep detailed records of material test, production processes, inspections and any corrective actions taken. And next is the compliance of the documentation, maintain records to demonstrate compliance with relevant code standard and project specification. And the third one is the traceability. We have to ensure that each precast element is traceable back to its production batch, including details about concrete mix, reinforcement and any quality control check performed. For example, for a large infrastructure project, documentation includes records of every precast element produced, ensuring that any future issues can be traced back to specific production details. And the next topic, that is the future trends in precast construction, that is our probably the last topic. The future of precast construction is shaped by technological advancement, sustainability initiatives and evolving design demands. Understanding these trends is crucial for staying competitive and meeting the challenges of modern construction. Firstly, we will talk about the automation and robotics, in which we have to enhance the manufacturing efficiency. Automation and robotics are increasingly being integrated into the precast manufacturing process. These technologies enhance efficiency, precision and the consistency while reducing labor cost and human error. Robotic manufacturing, robots are being used to automate repetitive tasks such as casting, formwork preparation and finishing, which improves production speed and accuracy. Automated quality control, automated system can perform real time quality checks during production, ensuring that each element meets exact specification. For example, in a fully automated precast factory, robotic arms can assemble reinforcement, pour concrete and finished surfaces, significantly speeding up production while maintaining high quality. Next is the advanced material, that is the incorporation of high performance concrete and composite. The use of advanced materials such as high performance concrete and composite material is becoming more common in precast construction. These materials offer superior strength, durability and flexibility, enabling more innovative and sustainable design. That they give the high performance concrete has highest strength and durability compared to conventional concrete, making it ideal for demanding structural applications. Talking about the composites, incorporating fiber reinforced polymers and other composite into precast element can enhance performance, particularly in terms of weight reduction and corrosion resistance. For example, a bridge constructed using precast element made of high performance concrete and composite reinforcement may have longer lifespan and require less maintenance compared to the traditional materials. Thirdly, we talk about the digital technologies, that is the use of BIM, that is the building information modeling for design and coordination. Digital technologies, particularly BIM, are revolutionizing the design, coordination and execution of precast construction projects. BIM facilities are give better collaboration among stakeholders, reduces error and improves overall project efficiency. BIM allows for detailed modeling of precast elements, including their structural, mechanical and static properties, ensuring accurate production and seamless assembly on site. Virtual prototyping, if we talk about, BIM enables virtual prototyping, allowing designers and engineers to simulate the construction process, identifying potential issues and optimize design before physical production begins. And last is the sustainable practices, that is greater emphasis on green materials and energy efficient designs. Sustainability becomes a priority in construction precast method, are increasingly incorporating green practices. This includes the use of eco-friendly materials, energy efficient designs and processes that reduce the carbon footprint of construction project. Its points include the green concrete, that is the development of low carbon and sustainable concrete mixes that reduces the environmental impact of precast element. Next is the energy efficient production. Factories are adopting renewable energy sources and energy efficient process to minimize the carbon footprint of precast production. Next is the life cycle sustainability, emphasis on designing precast element with long term sustainability in mind, including recyclability and energy performance over the building's lifespan. For example, as a residential project using precast wall with integrated insulation and low carbon concrete can achieve high energy efficiency and a reduced environmental footprint. Dear learners, we have reached the end of today's session. I hope you found it informative and engaging. Thank you for your attention. See you in the next class. Thank you.